Alright, so here, this bottom one is the engine load. This here is the coolant temperature. This here is the RPMs times 1,000. And this is the speed in miles per hour. As you can see here, we have our left and our right blind spot monitoring system. I realize that it says lane assist, but there was an issue, just a printing issue. And then here we have our red line indicator, where when the car exceeds 6,500 RPMs, that'll turn red. And then here we have the analog cockpit. As you can see, we're idling at about 1,000 RPMs, which matches here on the digital display. And now we're gonna go ahead and go for a drive around the block and ensure that the analog values are matching the digital values that we're reading from the ECU. Drive a BMW.
Your phone is so light compared to mine.
So this here is the blind spot monitoring system. Basically, we have a sensor on the rear right and the rear left side of the car. As a car goes into your blind spot, as you can see here, as we roll forward, the light will be on because the sensor is picking up the car in the blind spot. As you can see here, yellow means proceed with caution. Never just assume no one's there. And then red means there's a car in the blind spot.
Just passed it. There he is. Oh, there you go. Boom, got triggered. Another one. And just passed it. Boom, turned on. Okay.
Alright, so for this demonstration we're going to be showing off the backup camera. As you can see right now, we're currently in park. The backup camera will remain off in all gears except for reverse. So now I'm going to switch it to reverse. As you can see, the camera turns on. So let's go ahead and go find a parking spot and test it. Now we're in drive. Alright, so now I've found a parking spot I'd like to occupy. Put the vehicle in reverse, as you can see here, and we're going to go ahead and go back to the white perpendicular line. This example is not the greatest because these lines are slanted in the parking lot, but the system is working as designed. So once we enter the red zone, we have about a foot. So once we hit this rear one, that should be square. As you can see, it's not too shabby. We're about 2-3 feet tolerance. As I said before, this parking lot does have vertical or diagonal parking lines, but we were able to accomplish. So as you can see, the car is idling here, maybe 900 RPM, and we're getting data back. It's a little bit slow, might be partially because the print statement or that we're using Bluetooth versus USB, but it's working. This is a demonstration of our multi-threaded application running here. As you can see, we have the graphical user interface, and we're not in the car, so it's just getting this dummy data back in a progress bar. If you look closely, that's updating every second. And then also just to prove that another process is running. For example, if I jump these two wires, which simulate the reverse lights going on in the car, the backup camera is going to turn on. As you can see, on, off, on, off, well, all at the same time. Our background process is still running, so you can see the bar is still filling up right here. What I've built here is a blind spot monitoring system for my car. As you can see, I have this little sensor that emits radio waves, and I have this big metal computer case set at 2 feet or 24 inches. As you can see here, the sensor is connected to a Raspberry Pi Pico, so a very small and efficient device. It only uses, it's like less than 5 volts. Currently, my units are messed up, but as you can see, that's putting out 1.9 to around 2, which represents feet. So I'll start my hand at 1 foot. As I slide it closer, you can see that that distance changes. So there's 1 foot, here's 6 inches. As you can see, it goes to 6, 3 inches. So it's pretty darn accurate for a 10-cent sensor. So this is a blind spot monitoring system demo. As you can see here, we have 2 sensors which represent the right and the left side of the car, and they each correspond to an LED. So if the vehicle's within 2 feet for this demo, then the LED is going to light up. As you can see, they're both lit up because this is reflecting off the camera and this is reflecting off my monitor, which each distance is less than 2 feet. So if I point one up at the ceiling, that's greater than 2 feet. As you can see, one of the LEDs shut off. But this one is on because the desk is less than 2 feet away. Then vice versa. If I rotate it up, as you can see, that one's now at the ceiling, and you can see that the orange LED here is on, and the blue one is off because that distance to my ceiling is greater than 2 feet. So this is a demonstration video showing that we can run 2 of these sensors, one for the right and left side of the car. As you can see, they're both here. They're connected to the microcontroller, and then the microcontroller is getting power from my Raspberry Pi, as well as printing data out to it for debugging purposes. From here, we've laid out a big tape measure all the way from 0 up to 5 feet, as well as we have this large computer case that we're using to simulate the body panel of a car because it's made out of aluminum and steel. So coming down to the tape measure, as we can see here, the computer case is right about 3 feet. That's upside down to you guys. And if we look here on the screen, every second it's printing data out. You can see that it's reading approximately 3 feet. And I would like to have these running in parallel in code so that they're both actually executing at the same time. But this microcontroller is so fast that we can just run one after the other and query these and get the data back that it doesn't matter at this point.